On April 20, 2010, the Deepwater Horizon drilling rig exploded in the Gulf of Mexico. 11 men were killed. The well would flow for 87 days. The National Commission concluded the blowout was both foreseeable and preventable.
Section 1. The Macondo well blowout. The explosion on the $560 million Deepwater Horizon destroyed the rig, which sank 36 hours later, plunging the Gulf Coast into an environmental crisis. The rig was owned and operated by Transocean and was underleased to BP. They had budgeted roughly $96 million and 51 days of work to drill this specific well, located 40 miles off the Louisiana coast.
The Macondo well was situated under 5,000 feet of water. From the seafloor, it extended another 13,000 feet deep into the earth, tapping a massive, highly pressurized hydrocarbon reservoir. Drilling at this extreme depth requires a precise physical balance. The reservoir pressure pushing up must be perfectly counterbalanced by the downward pressure of heavy drilling mud pumped inside the wellbore. When that balance failed, the blowout resulted in the largest marine oil spill in U.S. history. Over 4 million barrels of oil gushed into the ocean over the ensuing months. The well wasn't finally capped until July 15th, causing severe, lasting impacts on the marine and coastal ecosystems of the Gulf. The government investigation determined that this catastrophic event was not an unavoidable accident, but rather a sequence of human errors and technical oversights. As noted on page VI of the National Commission report, the explosive loss of the Macondo well could have been prevented.
Section 2. The cement job failure. To understand the disaster, it's necessary to examine the technical failures that allowed hydrocarbons to escape, beginning with the cement seal at the bottom of the well. BP chose a well design using a long string production casing. This is essentially a single steel pipe running all the way from the seafloor down into the oil reservoir. To prevent oil from rushing up the outside of that casing, crews pump cement down to seal the annular space, the gap between the steel pipe and the surrounding rock. However, that primary cement job, designed to prevent upward flow, was severely compromised. On page 115, the report concludes, the immediate cause of the Macondo blowout was a failure to contain hydrocarbon pressures in the well. Weeks earlier, the rig suffered an event where drilling mud actually fractured the fragile rock formation at the bottom of the well. BP compromised on the cementing design to prevent fracturing that fragile rock again, choosing to pump only 60 barrels of cement. That is a very small volume for a well this deep. They also pumped it at a low rate of 4 barrels per minute, which meant it couldn't properly clear out the existing drilling mud to create a solid seal.
The cement mixture itself was also flawed. Independent testing by Chevron later confirmed that the specialized foam cement slurry designed by the contractor, Halliburton, was unstable. The Commission's report on page 118 states, Halliburton pumped foam cement into the well at Macondo at a time when all available test data showed the cement would be, in fact, unstable. This failure left the bottom of the well fully vulnerable to hydrocarbon intrusion.
Section 3. The negative pressure test. With the cement pumped, the crew moved to a crucial diagnostic procedure known as the negative pressure test. This directly evaluates the physical integrity of the bottom hole cement job.
The test involves removing the heavy downward pressure of the drilling mud, bleeding the internal pipe pressure to 0 psi, and observing the results. If any highly pressurized hydrocarbons are leaking past the cement and into the wellbore, the pressure on the rig's surface gauges will steadily rise. To run this test, the crew displaced thousands of feet of heavy drilling mud with lighter seawater. During the initial attempts on the drill pipe, the crew bled the pressure to 0, but upon shutting it in, the pressure immediately surged back to 1,400 psi. This was clear evidence that something was pushing back from below. Facing this surge, BP well site leader Don Vidrine insisted on testing a different pipe, the kill line. Opening this line yielded a reading of 0 psi. This created a direct physical conflict with the drill pipe's 1,400 psi reading. Because both lines went to the exact same place at the bottom of the well, it was physically impossible for one to read 1,400 psi and the other to read 0. The anomalous reading of 1,400 psi was incorrectly dismissed as the bladder effect, an unverified theory regarding fluid pressure anomalies. This rationalization overrode the clear physical evidence that hydrocarbons were leaking into the well. Page 108 of the report highlights this oversight. The well site leaders and crew never appear to have reconciled the two different pressure readings.
Based on the zero reading from the kill line, the test was officially declared a success. The National Commission report documents this on page 109. Nevertheless, at 8 p.m., BP well site leaders, in consultation with the crew, made a key error and mistakenly concluded the second negative test procedure had confirmed the well's integrity. This flawed conclusion allowed the crew to proceed with temporary abandonment, displacing the remaining heavy drilling mud that was holding back the reservoir's immense pressure. The investigation found an absence of standard procedures or formal training for negative pressure tests among BP and Transocean personnel. This lack of protocol directly contributed to the fatal misinterpretation. As the report states on page 119, it is now undisputed that the negative pressure test at Macondo was conducted and interpreted improperly.
Data from the rig shows the well pressure rising unnoticed during a critical window. At 9:08 p.m., pumps were shut down, and the drill pipe pressure rose 250 psi. At 9:14 p.m., the pumps were restarted, which obscured the warning signs of the impending blowout. It wasn't until 9:41 p.m. that the crew attempted a delayed and ultimately futile effort to regain control by activating the annular preventer.
Section 4. The blowout preventer. The blowout preventer on the seafloor represented the final physical barrier to stop an uncontrolled flow of hydrocarbons. The crew activated the preventer too late, as flow rates were already too high for the standard valves to function. Furthermore, the automatic dead man system, a failsafe designed to physically shear the pipe and seal the well if all power and communication are lost, failed completely. Post-incident testing revealed low battery charges in one control pod and defective solenoid valves in the other.
Section 5. Root causes and systemic failures. The disaster was not simply the result of isolated technical malfunctions, but rather a severe breakdown of management across the companies involved.
The Commission documented a pervasive operating culture where complex engineering decisions were continually made to save time and money at the expense of safety. Page 90 of the report concludes, but most of the mistakes and oversights at Macondo can be traced back to a single overarching failure, a failure of management.
Responsibility for the disaster was shared among the primary corporate actors operating on the rig. Also on page 90, the report states, better management by BP, Halliburton, and Transocean would almost certainly have prevented the blowout by improving the ability of individuals involved to identify the risks they faced and to properly evaluate, communicate, and address them.
The investigation revealed deep organizational flaws across multiple operational levels, pointing to a severe degradation in standard safety practices. BP made several concurrent engineering decisions regarding casing design and cement volume without fully evaluating the compounded risks of these choices. Key data regarding the unstable foam cement and the anomalous pressure readings were never properly shared or evaluated by the onshore teams. The decision-making process was highly compartmentalized. Page 223 of the report states, their management systems were marked by poor communications among BP, Transocean, and Halliburton employees regarding the risks associated with decisions being made.
The breakdown in safety management was not limited to a single entity, but represented a systemic vulnerability. The National Commission's final analysis on page VIV states, the immediate causes of the Macondo well blowout can be traced to a series of identifiable mistakes made by BP, Halliburton, and Transocean that reveal such systematic failures in risk management that they place in doubt the safety culture of the entire industry. The findings demonstrate that without rigorous adherence to safety over cost, the extreme risks of deepwater drilling remain fully present.